All right, so we've talked about probability before. So probability is favorable over total amount of outcomes. Okay, you've studied probability for years and years and years. But let's talk about geometric probability. So geometric probability is when you have some sort of geometric measurement, length, area, volume, anything to do with geometry. And you have a probability with that. Okay, so let's look at probability with lengths. So if you look at point X, randomly located anywhere on AD, find the probability. So what I already did is I counted how long AD is, which it's horizontal, so I can count 14 units. So then I just put that AB is 3, BC is 6, and CD is 5. Totals up to 14. So find the probability. Remember that probability, that capital P and E is a probability of an event, right? So let's find the probability that X is on CD. So CD is 5, 5 out of 14. X is on AC. AC altogether is 9, so 9 out of 14. And X not on AB. So AB is 3, so not on AB would be 11. And always make sure you reduce your fractions, but none of those reduce. Okay, point X is randomly placed on PT below. Find each probability. So X being on PR, I just measured PR as 22 out of the entire 40. So then reduce. X is on QS. So QS is 12 total out of 40, so reduce. And then X is on PQ or ST. So PQ and ST are both 14. So I just added up 28 out of 40 and then reduced. Okay. Their waiting times, I want you to go ahead and pause your video and read the top part, look at the picture, look at the work for 3 and 4. And then I also want you to do the same thing with number 5. Okay, so go ahead and pause your video. These are just waiting times, segment applications. I've not seen very many of these ever, but go ahead and try them. So there's number 5. Okay. All right, most importantly, let's go to probability with area. So it's the probability that a point lands in a certain region contained within the larger region. Okay, so if you wanted to know the probability of something landing right here as opposed to the entire thing, so then it would make sense, wouldn't it, that you'd find the area of the entire thing, right, and have the area of the shaded region and then divide that out. So if you look at this, this is the area of the rectangle, so that would be 23 times 11. And the area of the triangle is half base times height. So obviously 11 times 8 divided by 2. So then you just create that as a ratio. Okay. So it would have to ask you, it will tell you a specific, like leave it at fraction, turn it to a decimal, or turn it to a percent. I personally kind of like it as a percent because I feel like I know that 17.4% is not great chances, right? Okay, 44 out of 253, I know that's a bad score, but I like seeing the percent. So it just depends on what the question is asking you. You can do it all three: fraction, decimal, and percent. Okay, so this one, take the area of the square and the area of the circle and do the probability of the shaded region. So the circle, right, took up 50.27. So make sure you do these. But the square took up 64. So I have to do the favorable area. So I have to subtract these two. So make sure you subtract these two and put that on top. So go ahead and try that and make sure you can get the correct answers. Okay, still not great probability of landing in the shaded region on this one. It's only 21.5% basically. Okay, so finding the probability of the area of the shaded region. So I found the area of the triangle right here. And then I found the area of the semicircle. So pi r squared divided by 2, so half pi r squared. Okay, but since the shaded region is that half circle, I'm going to put that number on top of 600. So I don't have to do the subtraction here. So that's roughly 37.7 or 38%. Okay, so in this one, I have 4 semicircles, right? So I have 44.18. but I have 4 of them. Okay. And I also have the area of the square. So don't use 15. It's not 15. It's a 45, 45, 90. So I would do 7.5 radical 2 right here. Okay. I use 45, 45, 90. If you want to, you could use Pythagorean theorem. It's just they're both the same. Okay. So the total area would be 4 semicircles and the area of the square. So that's the total area. And then you want the area of the shaded region. So 4 of these on top. Okay, and when you divide that out, you get roughly 61%, which actually isn't too bad, is it? Okay, so that's number 9. Make sure you pause the video and try these. Okay, number 10. So number 10, a dart is tossed and hits the dartboard shown to the left. The dart is equally likely to land on any point on the dartboard. Okay, find the probability that the dart lands in the white area, find the probability that the dart lands in the light gray area, and then find the probability, we don't even have to do the dark gray. Okay, so this is dark gray, this is light gray, this is white. Okay, so find the area of the square, find the area of that circle, the white circle. Okay, and then we are going to take that white area out of the total area, just the white area. Don't subtract the white area out of the total. Not very good chances, 12.6%. Okay. B, find the probability that the dart lands in the light gray area. So look what I did. I did the area of the outer circle, the area of the inner circle. So the light gray would be those two subtracted. Okay, so the area of the outer minus the area of the inner, the area of the light gray is those two subtracted. So the probability is that area out of the total, 225, the square. Okay? All right, volume is the same thing. So go ahead and read these two. Volume is the same thing. You have a tank with a volume, and then we have a tank, the water filling the tank. Okay, so basically what they're going to do is they're going to tell you that the water is 2.5 inches from the top. So what is the height of the water right there? So the water volume is only to 13.5 inches. Okay, so the water area out of the total, there's your percent. Not bad. Okay, last one, volume of a cube, volume of a sphere. Okay, so it wants to know if a point is chosen at random inside the cube, what is the probability that it lies outside the sphere? So if it's outside the sphere, you had to find the volume of the cube, volume of the sphere, but you have to subtract them because we're talking about the leftover. And there's your percent right there. So check those, see if you can get all those correct. Make sure it's not a calculator problem. Good luck.